All right. Welcome back, everyone, to another Astronomy on Tap. Uh, Good to have you back in 2021. Those of you, this is your first time. My name is Michael Roderick, and together with Jacob Lund, Arvind Gupta, and new addition, Brianna Zwatsky, we run Astronomy on Tap State College. So tonight we are going to be talking about Planet 9, discovering a potential new planet beyond Pluto that is not Pluto, as well as We Could Not Fail, the story of the first African Americans in the space program. So to kick things off, we're going to get started with a astronomy themed cocktail. After that, we'll go on to our first talk on Planet 9. After that, we will have our trivia, followed by Astronomy in the News, our second talk with authors Richard Paul and Stephen Moss. And then we'll come back for our answers and trivia, and then wish everyone a good night. So let's go ahead and get started. I'll turn this over to Jacob, who's going to show us how to make our Astro cocktail. Go ahead, Jacob.
All right, hello everyone. So hopefully you saw the ingredient list on there. So today we're going to be making a twist on a tequila sunrise. And so as you might expect, we'll need tequila. I have here. We're gonna have some grenadine. We're gonna use a Corona. We're gonna have an orange for garnish, and then also some orange juice. So let's go ahead and start making this. We're gonna start, you also need ice cubes. We're gonna start with the tequila and the orange juice. So you're gonna need about a shot, 1.5 ounces of tequila. Oh dear, it's very tight. You pour that in, and we're gonna need 2 ounces of orange juice. So I'll give it a good shake. I might go a little above 2 ounces because I like mine kind of orangey. All right. And we're gonna put our ice cubes now. I'm gonna pull out our ice cubes, drop in 2 or 3. Chill. I'm gonna give it a little stir, mix it up nicely. And now comes the fun part of our drink. We're going to add in the grenadine. And this is what's going to give it kind of that sunrise, or in this case, sunset look. So we're gonna use 1 ounce of grenadine. You can see this bright red color. And now here's the trick. You can either use the back of a spoon or just pour it along the side of the glass so that it falls to the bottom and doesn't mix so much through the orange juice. So hopefully I can do this well with this little pouring implement. It's not the best. I also forgot to mention that this is going to come up pretty close to the top when we're all done. So make sure you have a large glass that can handle probably a little over exactly 16 ounces. Depends on how many ice cubes you put in. So here's my attempt at doing this. I'm gonna pour it down the side of the glass. Can't really see how well I did. How well did I do? Not too bad. There's a good gradient there. And we'll get a little more when we add in the Corona. And so you might be wondering why this is space themed. And while sunsets are, sort of space related, it reminds us of the Earth rotating and orbiting around the sun. Every day we get a nice, beautiful sunrise and sunset. But we're also doubling it up with corona because the sun also has an extended atmospheric layer called the corona, which eventually then forms into the stellar winds that it gives off out into space. So we're going to add this on the top, kind of simulating the top layer of the atmosphere, I suppose, of the sun. I'm going to pour it over the back of a spoon. Just I did it once and it kind of mixed in all the way. So I just want to be a little careful here and pour it maybe a little slowly so it doesn't completely ruin it, which it may anyway, but we'll see. We're just going to pour in the Corona. I think we're getting some mixing. Oh well. Pour it all the way to the top. If there's room, there might be a little bit left. Oh, that's not too bad. So we've got a nice gradient. I don't know how well you can see it here. And then we're gonna top it off with just a nice little orange slice that reminds us of the sun. And while we're talking about the sun, the corona is interesting because it's many million or up to 1,000,000 Kelvin, which is a very hot temperature, which is much hotter than the actual surface or the photosphere of the sun. So one of the weird, interesting questions is how it becomes so hot. Because if you imagine if you're around a campfire, there's warmth from the campfire. If you go further away, it gets colder. But the inverse actually happens with the sun. The further you go away from this, basically the sphere, the photosphere of the sun, it actually gets hotter and much, much hotter. And so we're not entirely sure why that happens. And so that's an active area of research. And so there we go. We'll plop our orange on the top. Corona sunset is what we're calling this. Here's our nice corona sunset. So cheers, Michael, Arvind, Brianna.
Cheers.
Happy astronomy on tap.
Yeah, I did not follow the instructions and mine just completely mixed, but it still tastes really good.
That's
I like
Yeah,
it.
that's okay. I end up mixing it around because I don't really like the flavor of the Corona right on the top, and I think it's better if it's mixed anyway, but it's cool to present, and then you mix it up behind the scenes. So that's what I'm going to be doing.
Awesome. All right, well, thank you very much, Jacob. Now that we all have our drink, we can go ahead and get listening to some astronomy. So our first talk of the night is going to be by Malena Rice, a graduate student at Yale University, and she is going to be talking about Planet 9, potentially discovering a new planet. Go ahead, Malena.
All right, thank you, Michael, for the introduction, and Jacob for the awesome tutorial. I really wish that I had all of those materials with me, but I should have prepared. So I'm just going to share my screen now and get going. All right, so I'm super excited to be joining today, first of all. I have been to lots of Astro on Tap events, but they've pretty exclusively been in New Haven, Connecticut, which is where I live. So it's been really wonderful having the opportunity to visit other Astro on Taps and sort of see how the other ones are run and how I guess, like different types of astronomy on taps around the world. So today I'm super, super excited to be talking to you all about a question that has really captured my interest over the past couple of years, and that I personally think is one of the most fascinating questions that is being pursued in astronomy right now. I know I'm a little bit biased because it's what I work on, but I wouldn't work on it if I didn't think it was really interesting. And that question is, what if the solar system planets that we know of and that we learned about in elementary school and that, just seem like, oh, those 8 planets that we know off the back of our hand, what if they're not the only ones? And yes, there are thousands of planets that are around other stars and that have already been found. There are lots and lots of other planets that are out there that are not in the solar system, and they're wonderful. They're super interesting as well. But what if there was another one that was in our solar system? And that's what I'm going to be talking about today. And in fact, there is a proposed 9th planet that has never been observed. And this raises a lot of questions. So what would it look like? How different from or similar to the other solar system planets would it be? Why haven't we found it yet if we think it might be there? What can we learn from it? But let's maybe start the story from the beginning. So why do scientists think that this planet might exist in the first place? Well, our classical picture of the solar system is a relatively tidy one that looks like this, where the sun is on the left and our 8 planets are shown in order. And this image doesn't quite capture all of the details of that system. So the planets are not shown totally to scale. The distances between the planets are not to scale here. There are asteroid belts, there are moons and other parts of the system that are not within this picture. But in other ways, this actually isn't all that inaccurate. All of the known solar system planets actually do lie neatly in approximately the same orbital plane. The largest inclination away from that plane is Mercury at around 7 degrees. of these 8 planets. And so this sort of leads to this nice and relatively simple picture where all the planets formed in this nice disk of material. So it's a flat disk of gas and dust that ends up coalescing into the planets that we see today. And that's a really lovely picture, and that's still probably correct. But the more that we've looked towards the more and more distant solar system, the more it looks like there's more to this story that we haven't really totally unraveled yet and that we don't entirely understand. So this picture is actually only showing the inner 30 astronomical units of the solar system, where the known planets lie. So an astronomical unit is defined as the distance between the sun and the Earth. So again, this picture isn't shown to scale, but Neptune is 30 astronomical units from the sun. So that's kind of the outer edge of the solar system that I'm sort of defining. There are more precise definitions of what exactly that outer edge is, but for our purposes, the outer end of the solar system is just where there aren't any planets anymore that are known. And it turns out that there are actually a lot of objects that are beyond this inner solar system that we're aware of. In particular, there are solar system bodies that are known as extreme trans-Neptunian objects that have been discovered far beyond the orbit of Neptune. These are large asteroids that can be up to hundreds of kilometers in size, which is actually the only reason that we can see them. Even though they're so far away, they'd have to be pretty large for us to actually be able to see any of them. But this population isn't too well understood, and its constituents show a few unusual properties. So this image is showing the orbits of the known stable extreme trans-Neptunian objects that have been discovered so far. And you might notice a couple of pretty clear patterns here. So first of all the orbits are not circles, they're pretty elongated. So this means that instead of following nice circular orbits, these bodies are on these really eccentric, sort of long, squished out orbits where they're not going on these nice, simple circles like the solar system planets that we know of are. And so that's one of the first patterns that you see. And you'll also notice that all of these orbits tend to be clustered on one side of the sky. And this is something called apsidal alignment, which just means that all the orbits are like facing the same way. You can't really see this in the 2D image, but the orbits also tend to all be roughly in the same plane, and they're sort of more inclined relative to the solar system planets. So they're not in the same plane as the rest of the solar system, or the solar system planets at least. And all of the orbits share the same roughly orbital plane, or it's more clustered than you would expect, similar to the way that these angles are all clustered, so the orbits are all on one side of the sky. So this is really weird for a couple of reasons. First of all, there isn't a good reason that the orbits should be clustered at all. They should actually precess around the sky over a timescale of about 1 billion years, and the solar system's around 4 billion years old. So that means that we should have seen these spread out a long time ago, and they really shouldn't still be clustered in the same position if there's nothing that's holding them in place. And so you could argue that maybe a passing star could have gravitationally perturbed all these orbits and forced them on one side of the sky, but we don't expect that these close stellar passages would happen all that often in the past 1 billion years or so. The fact that all these objects aren't in the same plane as the solar system is pretty weird too, because since all the solar system planets are just in this sort of flat plane, they can't actually push other material upwards very easily. So you can think of this sort of like when you're playing pool on a pool table. If you hit a pool ball and it hits another one, then it's just going to move in that same plane parallel to the table. And unless you induce some force that actually makes it leave the table, so you'd have to somehow push it up with your pool cue, it's not actually gonna ever go up. There's no reason that it would. There's just nothing that is providing a force that would make it go up. And so that's sort of similar in the solar system, where we wouldn't expect to have anything that really gets pushed upwards in the same way that these orbits are, if there isn't something that's outside of this plane of the solar system that would be producing that effect. So this population is the groundwork upon which the proposition of a 9th solar system planet lies. If there was a 9th planet, then it could help to explain these problems. It would solve a lot of the mysteries in the outer solar system at the same time. So it would be a relatively simple way to explain these strange phenomena. And if it isn't in the plane of the rest of the solar system planets, it could produce this force that makes these objects reach these higher inclinations that are outside the plane of the rest of the solar system. So what properties would this planet actually need to have in order to solve all of our problems? Well, if we return to our simple solar system model and we zoom way out to show all of our distances to scale, if planet 9 exists, and that's a big if because it's, again, never actually been observed, it would need to be located at a distance of 400 to 800 astronomical units from the sun. So that's about 10 times or more distant than Neptune. It would have a mass of 5 to 10 Earth masses. It would be inclined by about 15 to 25 degrees relative to the solar system planets, and it would be on a fairly eccentric orbit. So it would also have sort of a stretched out orbit like these other distant objects that we've seen. And it seems kind of weird that we wouldn't actually have seen such a planet if it existed yet, because, you know, we've had surveys that have been looking all over the sky for lots of different things in space, galaxies, stars, other planets. And so it seems a bit odd that we might have missed something in the solar system, but it turns out that there's actually a region of space where we wouldn't have expected to see anything. And so this is shown by this plot that is here, where we're now looking at, okay, if we just consider everything that we've observed before, everything that we would have expected to see, what remains, and where could we still have a planet that we would have somehow missed? So if there was another planet out there, it would need to be small enough that we haven't actually seen it with any of these surveys in the past. It would have to be big enough that we call it a planet. So this is just the definition of a planet versus a dwarf planet. It would have to be near enough that it remained bound to the sun when it was first born. So the sun probably was born in a stellar cluster amidst many other stars, and they would interact every so often. There was a higher stellar density near the sun at that time. And so if there were planets that were too far away, then they would just get knocked out of the system. And so there's sort of this dividing line where we think that it probably wouldn't have actually stayed stable if it had formed this far away. And it would also have to be far enough that we haven't actually seen any signatures of it other than these distant outer solar system objects. So we pretty precisely know where a lot of the material in the solar system is. So we know where our spacecraft are, we know where the planets are to quite high precision, and we would have been able to see a perturbation from something that was too nearby and too massive. And so that's what this constraint is that is shown on the left. And it turns out that the planet 9 that I mentioned, it lies like right in the middle of this shaded region where a planet could still potentially exist. And that's exactly the type of planet that would help to solve all of these issues that we've been seeing in the outer solar system. So it could interact with the other outer solar system objects and produce the properties that we have observed. And so, okay, how do we actually look for this planet? Well, this is what my research is focusing on. I'm using a data set from the Transiting Exoplanet Survey satellite that is shown here. So that's also known as TESS. And it is being used, well, it was designed to search for planets around bright stars that are in the solar neighborhood. So it's actually not meant to look for planet 9 at all. It was designed to search for these undiscovered planets, and it's really wonderful at what it does. It seems like it's been finding planets every single day, but I think it's already found thousands of planet candidates, and they're constantly being confirmed all the time. But it turns out that TESS also, because it's observing so much of the sky, is producing this amazing gold mine of data to look for planet 9 as well. So over the course of its survey, TESS observed nearly the entire sky outside the plane of the solar system. So that's this gap that you can see in between the top and the bottom halves of this sphere here. That's where the solar system lies, and this survey is looking outside of it. And that's exactly where we think planet 9 would exist. TESS is staring at each point for 27 days. So we have nearly a month of light from every single part of the sky that is collected continuously, which is great. So if this planet exists, then we're probably collecting some light from it if it's anywhere within this field of view. And that shows us that we basically have 2 missions for the price of 1, which is wonderful. We have this great mission to study exoplanets and another that's really ideally suited to search for this undiscovered 9th planet and to see if maybe it actually does exist and if we can actually find it. So to recover the signals of extremely distant objects, though, Objects in the solar system are actually moving over these relatively short timescales relative to Earth. And so we need to actually collect all of that light into one place since the object's moving, and we need to make sure that all the light is added up together to actually find these extremely dim objects. So we accomplish this through a method called shift stacking, where if an object moves across your frame like this, then that's the same thing as just changing your frame of reference and then sliding the picture past. So if you just follow the object's frame of reference and slide the picture instead, then that's actually the same thing. It's just looking at the same positional change in a slightly different way. And this illustrates how our survey works. We take a month of data from tests, we pre-process to remove stars and systematics, asteroids and other things from our light curves, and then we stack all of our pixels along an object's actual orbital path. So here we're showing real test data from the spacecraft on the left and an actual recovery of Sedna on the right, where we took this image, we removed all the stars, and we took all the other images from the same part of the sky, and then we stacked them along Sedna's path, where Sedna was in these white circles at different points in its orbit. And you don't see anything in these white circles right now because just there's so much other stuff going on in the frame. You're not going to be able to see it unless you subtract out the stars that are making the frame much noisier. But once you've done that, you can actually really nicely pick out these super dim signals. And this object is about as dim as we think Planet 9 should be. So that's super promising. That's showing us, okay, we know that if Planet 9 is in there, then, and if we knew where it was, then we should be able to recover its signal. This video is another way to visualize that process that might be maybe a little bit more intuitive. So the left panel is actually just a video of a part of the solar system that's in the test data set. And all these little bits of light that are moving past are asteroids that are passing through the frame. And so I think over the bandwidth of Zoom and the lag of YouTube, you might have trouble seeing this video in real time. And so you can go to this link if you'd like to look at all of the frames in a little bit more detail. But on the left, you're seeing just a video of the sky after we subtracted out the stars. And on the right, you're seeing our recovery of Sedna. So we just add together all of these frames until we actually pick out that really dim object. Which is amazing because, again, these objects are so dim that we're never going to see them in any of these individual frames. And so the fact that we can actually recover them in any way is really exciting and shows us that we're able to use this really extensive data set to look for something like Planet 9. So I just showed you how we could find known objects though, but how can we actually find undiscovered objects? Well, this is just showing a schematic of the two different methods that we're using, where the top row is just showing how you would find a known object and the bottom row is showing how you would find an unknown object. And effectively what it's saying is you just check every single path and you check all of them and create an aggregate frame that gives you the information that you can extract from every single one of those shift stacking paths. So I call that a best ever frame, and that is just retaining the best possible candidates from every possible shift stack that you're trying. And if you try every orbit that could possibly exist, then if Planet 9 exists on one of those orbits, then you should actually be able to see a nice signal pop out. And so we demonstrated this in a recent paper that I wrote. And in the leftmost column, you can see if we just know where the object is and we just shift and stack in the way that that video that I showed just earlier does, then you can nicely pick out the locations of each of these three test objects that we ran through our algorithm. These are progressively dimmer. So the top row is the brightest object, middle is a little bit dimmer, and the bottom row is the dimmest. So we're really just trying to see how dim can we go? What types of objects can we see? And this kind of spans the entire range of what we think Planet 9 might be in terms of how dim it would be. So even though these objects are they're much smaller than Planet 9, they're not like planet-sized at all, but they are much closer, and so they still end up giving us about the same amount of light. And so the leftmost column here is showing each of these objects recovered when we know where they are and we tell the algorithm where they are. But in the second and third columns, we're actually not giving the algorithm any information about where the planet is or where the asteroid is. We're just checking every possible path and seeing what pops out. And that's really exciting that we actually get the same signals out. They look a little bit different because, again, this isn't quite the same way of searching. We're searching over every path instead of just one, but we're able to really nicely pull out the signals of these objects, even without telling the algorithm that they exist at all. We just say, look for anything that is in the outer solar system and see what you find. So that's really exciting, and it's something that we're now working on applying to the entire sky. So we've shown that this can work for some of the known objects and it can recover them. And now we want to look for Planet 9 with it. So I've been working a little bit on just improving our methods to make sure that our data processing is as clean as possible. We're actually removing all those asteroids that, even though they look really cool in the video, they're noise in this particular search. We're also using machine vision in order to automate this search. So we want to not look through all 17 terabytes of data by ourselves. And so we're using machine learning to make that a little bit easier. And then we're just going to search the entire sky and see what pops up. And this is something that actually should be complete within the span of the next year or so. And so keep an eye on this. I hope I've convinced you that this is a super exciting topic, and Planet 9 in general is something to keep an eye on. We might possibly have another planet added to our solar system pretty soon. So thanks so much for listening. I hope I've convinced you that this is a really exciting topic. I am super psyched about it, super happy to answer any questions, and thanks all for being here.
Awesome. Thank you, Malena. So yeah, if you do have any questions for our speaker, feel free to type them into the chat. We can ask her while she's still here. So we do have a question from the audience. So when we were looking at one of the early plots we had that had the orbits of all these elliptical trajectories around the sun, the question is it possible that there are selection effects going on? You said that we can't see all these objects due to their size. Could the actual complete set possibly fill out an even distribution?
Yeah, so that's definitely possible. And that's something else that we're trying to figure out with this survey, because we're looking for anything in the outer solar system. So it would also be really interesting if we found more of these orbits on the other side of the sky. And then that would tell us, oh, maybe we don't need a Planet 9. But until we really have a thorough survey that has been conducted uniformly across the entire sky, it's a little bit difficult to conclusively answer that. There have been arguments both ways. So I've seen papers that have said, oh, this is definitely statistically robust, and others that say, I don't know, I'm not really so sure. And so there's not really a
Typical academia.
Yeah.
So interesting kind of follow-up question. What would the process be for adding it officially as a planet if you find it? And I guess kind of another follow-up question on that is, what is the definition of a planet now? It's been through several iterations. Do we have a concise definition for what is a planet?
Yeah, so I think I'm not bold enough to have actually looked into how to name a planet. I figure if I reach that road, I'll cross it then. But yeah, I think you would take it to the International Astronomical Union, and then you would have to go through some process to name it. You probably can't name it anything you want, but I think
that's actually correct.
Yeah. Yeah, so I'm pretty sure, like, you can't just be like, oh, I found a planet, I'm gonna name it Bob and just call it. Like, I think there's a more formal process than that. But
Yeah, I think Uranus, right, was supposed to be named George after King George, and they're like, no, we're not going to do that.
yeah, that would have been very different. It would probably have to fit in the pattern of the rest of the planets, I'd imagine. But yeah, we'll see. We'll cross that road when we reach it, if we do. And for the definition of a planet, so a planet needs to be, this is kind of a sticky question, because there's not a very clear distinction between the largest planets and the smallest stars, and there's also not a very clear distinction between the smallest planets and then dwarf planets. But to my knowledge, I think a planet is typically a rock. Well, it's not necessarily rocky. It's typically an object that's smaller than a star that can clear its orbit. So that's why Pluto is not considered a planet, because it can't actually clear the other material in its orbit. And it needs to not be big enough to be fusing deuterium or hydrogen or anything else. So stars are actually fusing material inside of them. And there are some planets that are so big that it's actually not totally clear whether they're stars or not, or if they're planets. Yeah, so it's kind of a that's very tricky once you get to the boundaries. But if it's 5 to
Yeah.
10 Earth masses, then it's quite likely a planet. I don't think there's
All
anything else
right.
to call it.
So another question from the audience: if the planet has a very low albedo, could you still find it? I guess another way, like, what is the limiting albedo? What is the limiting brightness of that planet?
Yeah, I think it's so there have been papers that have like explored the expected albedo, and it's not expected to be very dark, but I haven't actually looked at them in enough detail to tell you exactly what that albedo limit is. It's true that if the planet was dark, then we wouldn't be able to see it with these surveys. So what we're looking at is reflected light from the sun. So light is being sent to the planet and then it's sent back to us. And so the farther the planet is, the harder it is to see because of that, because the light drops off really quickly with distance. But if the planet is really dark, and so that's what this word albedo means, that's just how reflective it is and how much light it's able to actually reflect. So if you have a perfectly black planet, then it's not going to reflect any light. It might just absorb all of it and you'll never see it. And if that was the case, then we wouldn't see it. So it is pretty hard to conclusively say the planet does not exist. You could look for it with gravitational methods. So you could say, oh, well, if we do have a planet there, then it should interact with everything else in the solar system so we can see if we are able to observe perturbations of that type. But it would take a lot of measurements over a lot of years. So, and they would have to be very precise measurements. So likely stellar occultation measurements or something else that can get positions of objects in the solar system to really, really small error bars.
And there was a paper by Mike Brown several years back that they were looking at some orbits of some far out objects, and that it suggested that there was possibly a massive object there causing these perturbations. And I like haven't totally followed up on that at all. I'm wondering if you know, has there been any more follow up into that?
Yeah, I'm not sure which paper you're talking about, but that's really interesting. I'd be really
It,
interested to read that.
yeah,
Uh,
as much as an extragalactic astronomer knows about solar system planets, it was just like a passing glance kind of thing.
yeah,
Um,
I know uh, people have tried to actually figure out where Planet Nine would be based on looking at the location of Cassini. So that was a spacecraft that was orbiting Saturn for decades, and spacecraft in the solar system, we actually have to keep track of their locations to very, very high precision if we want to continually get data from them. And so that was actually some of the most precise positional measurements of anything in the solar system that we've ever gotten. And so with that data set, they tried to figure out if Planet Nine existed, where would it actually improve our models? So there are locations that it could be where it would actually make our models of the solar system dynamics better. But the problem there is there's also a lot of other stuff in the outer solar system that is just in smaller bodies that we can't resolve. And so it's kind of hard to actually differentiate Planet Nine from like other stuff in the Kuiper Belt that is just like lots of small rocks that add up to actually quite a lot of mass, but the individual bodies you can't really see.
yeah. And then we've got this upcoming LSST survey, which is just going to generate a massive amount of data staring at the sky night after night. Can that be used to try to find these kind of hidden planets?
Yes, definitely. So if Planet Nine is out there and it's not found with LSST slash the Vera Rubin Observatory, then I don't know. I mean, we can't say it doesn't exist because again, there are always ways that it could exist. It could have a really, really dark surface. It could, I don't know, be like right next to a really bright star, so we wouldn't have seen it. But there, it's pretty unlikely that it would be the planet that we have predicted if we didn't find it with LSST. And so it should be found within the next decade, I'd say, if it exists. But we can't say like 100% certainty that it's not there. We can just say it seems unlikely because there are very few places that are left to hide.
Okay. All right. Well,
Yeah.
one last question. What sort of machine learning algorithms are you planning on using for your research?
Yeah, we're using convolutional neural networks. So we're using
Totally know what that is.
image processing. It's a big data set with lots of images. And so we're looking for these bright sources that come up after our blind searches. And we're just going to use the neural networks to hopefully reject lots of false positives and accept the more promising candidates, and then follow them up with ground-based telescopes afterwards.
And if that fails, you just have undergraduates, right? Like they got plenty of time. They can get through this.
Yeah. Yeah, I've actually had like some really wonderful amateur astronomers reach out and offer to help, which was so great because honestly, we need all the help we can get. So very exciting to have other people excited about the project as well.
Awesome. Well, thank you so much for coming out to give us the talk. We really appreciate it. Good having you here, Malena.
Yeah, thanks for having me.
All right. Let's get on with trivia. So we have a link to the trivia sheet, which I am going to paste into the chat. And I'll have Arvin come online and start the trivia.
All right, thanks, Michael. And great talk, Malena. So can you see my screen now, Michael?
Yes.
Awesome. So for those of you who are showing up for the first time, welcome to Astronomy on Tap State College. The way we do trivia is each month we'll have a theme. As you can see here, this month's theme is the moon. And I'm going to ask you a series of 15 questions about the moon. Some of them require specific astronomy knowledge, others are just more general information. And there are some that are just kind of a toss-up where you have to guess. And there's this URL link on the bottom of the screen here. Michael also put it in the chat, I believe. So follow that. That's the answer form. Just submit your answers there as I go through. And the team with the highest score at the end of the round will be chosen, and we will send you some prizes. In the event of a tie, so if two teams, for example, get 13 out of 15 correct and nobody else gets that many, then I will choose the winner based on what I think is the most creative astronomy-themed team name. So if you think you're doing well, try to come up with a fun name as well. So the prizes we have tonight, we have some Astronomy on Tap beer koozies, some bottle openers from the Central Pennsylvania Observers, that's the amateur astronomy organization in the area. We have magnets, and we also have some face masks that were knitted by our friend Macy, or sewed, I guess, not knitted. You should be able to see one right here that I'm holding. They have a really cool galactic nebular pattern on them now. We've got about a dozen or so of those to give out over the next few months. So that's what you're competing for tonight. I always start with an example question. So our example for tonight, since this is the moon, how many natural satellites does the Earth have? You should know that the answer is just one. The moon is our only natural satellite. We have thousands and thousands of other satellites orbiting us in space, but those are all artificial. Those are things that we humans launched up into space. Okay, question number one. What is the current phase of the moon? So this is the phase of the moon if you were to look outside your window right now and tell me what it looks like. So the four options here are a waning crescent, waxing crescent, waning gibbous, and waxing gibbous. I've also put the current image of an image of what the current phase would look like on the slide here for those of you who it may not be nighttime yet, or you just may not be able to look outside. Number two, which of the lunar maria has the greatest diameter? So the lunar maria are these dark regions on the surface of the moon here. Maria means seas. Early astronomers, I don't know how early, thought they might have been actual oceans and seas full of water. So the question is, which of these is the largest? Number 3, which Apollo 8 astronaut took the famous photograph Earthrise? So Apollo 8 was the first mission from the Apollo program to send humans out to the distance of the moon. So this crew didn't land on the moon, but they did orbit around it. And one of the astronauts on board took this amazing photo of the Earth back in the, I think this would have been actually 1969. Yeah,
68.
68. Okay, sorry. Number 4, how many times weaker is the gravitational acceleration on the surface of the moon relative to the Earth? Is it 2 times weaker, 3 times weaker, 6 times weaker, or 11 times weaker? So this equivalently would be how much less would you weigh on the moon than on the Earth? Number 5, which is larger, the moon or Pluto? And I've tried to make these images the same size so I don't give you a clue. But yeah, one of these, one of either the moon or Pluto is larger / smaller. Number 6, which of these landing sites was the location of the first moon landing? So these are actually all 6 landing sites from the Apollo missions. We sent lunar landers that landed at each of these sites, but only one of them was from Apollo 11, which was the first landing. So I want you to tell me which of these 6 sites was Apollo 11. Number 7, how long does it take light to travel from the moon to the Earth? This is a finite amount of time. It's always the same. Well, it's going to vary a little bit as the distance between the Earth and the moon changes over the moon's orbit. But yeah, the amount of time it takes for light to travel from the moon to the Earth. And I will allow some margin for error. You can be a little bit off from the correct answer. You don't need to be precisely correct, but I won't tell you the margin because that would kind of give away what the order of magnitude is here. Number 8, roughly how many days does it take the moon to orbit the Earth? And I'm asking about a sidereal orbit here. So this is the moon orbiting Earth with reference to background stars, not with reference to the sun. So if we were to look at a star somewhere in the night sky, I want to know how many days it would take the moon to return to that same position. How much fainter than the sun is the moon? Is the moon 3,000 times fainter, 25,000 times fainter, 400,000 times fainter, or 2 million times fainter? Here I'm referring to the full moon. So when the moon is reflecting the maximum possible amount of light, not when it's at some less filled phase. Number 10, what fraction of the lunar surface can be seen from the Earth? And as you can see in this little animation here, the actual face of the moon that is pointed towards the Earth varies a little bit as it wobbles during its orbit. So the moon is tidally locked, which means that its orbital period is roughly the same as its rotation period. So one face is always facing the Earth, but it is also just wobbling a little bit in that tidal locking. So we get to see more than 50% of the moon all the time, or not all the time, but over the course of its orbit. Number 11, how many people have walked on the surface of the moon? I think I asked this question during a previous trivia as well. So if anybody was here for that and remembers the answer, congrats to you, free points. Number 12. So the question here is by how many degrees is the moon's orbit inclined relative to the Earth's orbit around the sun? So again, as in Malena's slides, these are not to scale. This is not the actual distance between the sun and the Earth and the moon. And this is not the actual inclination, but the moon orbits slightly out of the orbital plane of the Earth. And I want you to give me here how many degrees out of the plane its orbit is. Number 13, how did the lunar maria form? I'm looking for a 1 to 2 word answer here, just a short description of how all of these dark regions on the surface of the moon actually formed. The answer is not water. Number 14, which Apollo 11 astronaut piloted the command module while his crewmates landed on the moon? So Apollo 11 famously was when Neil Armstrong took the first steps on the moon, said his famous quotes, but there was one member of that crew who stayed in the command module, was not in the lunar lander, and I'm looking for his name. Number 15, was the Apollo 11 moon landing a hoax? This should be free points for everybody. Please don't get it wrong. So I'm going to go back to the first question now and just flip through these slides really quickly. I'll spend a few seconds on each, just so you can remind yourself of what the options are. But we're going to ask you to finish and submit your answers by the end of Astronomy in the News. That's our next segment. Astronomy in the News is short 5 to 10 minutes directly after this, and Brianna is going to tell you a few fun things about what's happening in the world of astronomy. 5, 6, 7. And all these questions are also in the trivia form. I'm just going back through to give you a bit more time, and so you have a chance to see the images. I'm not sure if those will help though. Okay, that's it for the trivia. We'll come back after the last talk to share the answers and tell you who the winner is. So with that, I will hand it back off to Brianna.
All right. Well, I was just here to say, here's Brianna. So go ahead and take it away.
All right, great. So there is always something exciting going on in the world of astronomy. And something that you may have seen making headlines this week was some information about WASP 107b, which is an exoplanet. A little bit about this planet before we dive into the new and exciting news. WASP 107b was discovered in 2017, and it's a gas giant that's comparable in size to Jupiter. It was discovered using the transit method, which we've talked about in past months if you've tuned in before. So the planet is going to block starlight, and that's how we find out that it's there. So with the transit method, we can determine a planet's size. So that's how we knew that it was roughly the same size of Jupiter. We didn't have a lot of information about its mass, but we also knew that it orbited very close in to its host star, with its year being only 5.7 days long. So compared to Earth's 365.25 days, much, much closer. You might be wondering what brings this back into the news if it was discovered a few years ago, back in 2017. And there were some headlines popping up this week talking about how this exoplanet is a super puff, which we'll go into more detail in a moment, how it's strange, how it's as dense as cotton candy, which is definitely, it grabs you in, because you don't usually think about planets as being compared to cotton candy. So what this recent study did was constrained the mass of the planet. And they constrained the mass of the planet by looking at it through the radial velocity method, which looks at how the planet pulls on its host star and detects the wobble. And from that, we can find the mass of the planet. And we found that WASP 107b is only about 30 times more massive than Earth, which is a lot less than we expected. Since this gas giant is roughly the same size as Jupiter, we thought it would be more along the mass of Jupiter, which is 300 times as massive as Earth. This ends up working out to roughly the same density as cotton candy, as that previous headline showed. And these really low density exoplanets are sometimes called superpuffs. So if you're interested in this planet, I encourage you to do a quick Google search and I'm sure you'll find a bunch of articles because I was seeing these headlines popping up everywhere and all over Twitter. And this discovery is really exciting because it's going to allow us to learn more about how these super puff planets may have formed. So the team that led this study is thinking that WASP 107b likely migrated from its initial position much further out, like about 1 AU from the star, which is where the Earth lies relative to the sun. And it would have migrated in closer to the star to get that 5.7-day orbit. And hopefully with future telescopes and future missions, we'll be able to learn even more about this planet and even more about how super puff exoplanets form. And maybe we'll even find some more cotton candy planets in the future. That's all we have for astronomy in the news this week.
All right, thank you, Brianna. Of course, we all want to know, does it taste like cotton candy? Well, if you want to know, write your senator, tell him we need to fund NASA, get a ship out there. All right, so if you haven't already, please do submit your answers for trivia. We're going to go ahead and get started with our next talk. So tonight we have the authors of We Could Not Fail, Story of the First African Americans in the Space Program, Stephen Moss and Richard Paul, here to tell you all about their book. So I will hand it off to them. Thank you.
Thanks, Michael. It's really, really great to be here. This is a fascinating experience. I've never done one of these before, and it's really nice to be here. We're here tonight with you to talk about our book, We Could Not Fail, which talks about the first African Americans in the space program, and also about NASA's role in civil rights in the years before the Civil Rights Act, which I imagine most of you are too young to remember. This was the time when it was legal in a lot of places to say, no, you can't eat here, you're Black, or no, you can't go to this school, you're Black. So the book is about NASA's role in civil rights in the years before that. And we'll be talking about a little bit about the rules that were put in place by the Kennedy administration to try and address workplace discrimination and how those were implemented at NASA and its contractors. But equally as important, maybe more important, we'll be talking about the people whose lives were touched by those rules. Our book tells the story of 10 men, most of whom came to work during the period that we now think of as the civil rights movement. Some of them were NASA employees, and some of them worked for NASA contractors. So Stephen is now going to talk a little bit about what President Kennedy did.
Yeah, President Kennedy signed Executive Order 10925 on March 6 of 1961 because he understood the political realities of his time. Executive power allowed him to address the problem on his own, to demonstrate action on civil rights without having to work through Congress. And this slide shows how the order affected federal agencies and their contractors. When the order was issued, it covered 38,000 federal contractors. So the impact of anti-discrimination clauses was potentially immense. At the time, NASA was a young and relatively small agency, but as it and its mission grew, so too did the importance of the order and the PCEEO on agency affairs. The president's executive order required federal contractors to be equal opportunity employers. Soon after Kennedy announced plans to land on the moon, national firms with connections to the Marshall Space Flight Center in Alabama began to advertise for engineers and technicians around the country. NASA contractors quickly proclaimed themselves to be EOE compliant, but not every vendor embraced that order. In July 1961, Houston Power and Light cut power to the Pelican Island destroyer base in Galveston, Texas, thus jeopardizing Houston's hope to host the Manned Space Flight Center. The company objected to the inclusion of an anti-discrimination clause in its contract with the Navy. Vice President Lyndon Johnson called Albert Thomas and told the Houston congressman, "Shall I tell the president that you cannot supply power to a Navy installation there because of the Negro question? And what are you going to do about space?" The Navy got its power, and Houston remained a viable site candidate.
So the government had its role, but probably equally important is the bravery and work of people on the ground. And we tell a lot of those stories in the book. One of the people who we talk about is Julius Montgomery, who actually died just this past February. He was 100 and something years old. Julius was the first African-American hired at Cape Canaveral as anything other than a janitor. He was what was called a range rat back in the 1950s. When a missile if a missile would misfire, the range rats would go downrange, get the missile, figure out what went wrong, and go in and fix it. So he did a lot of work with soldering and putting missiles together and taking them apart. He came to work in the 1950s during a time when the area around Cape Canaveral was completely controlled by the Ku Klux Klan. The sheriff of Orange County was a Ku Klux Klansman. One person who we did research with for the book told us that local businessmen would join the Klan just like joining the Rotary Club. So thinking about all of that, this is how Julius describes his first day coming to work at Cape Canaveral.
The first day I was there, nobody would shake my hand. I got to the last fellow. I said, "How are you? I'm Julius Montgomery." And boy, you don't talk to a white man like that. I said, "Oh, forgive me, oh great white bastard." I really did say that. And he laughed, I laughed, and then we shook hands.
That is the way that Julius navigated through his career at Cape Canaveral. I'm guessing you could hear that. Stephen, nod if they could hear that. Okay, great. In addition to being the first African-American hired as a professional at Cape Canaveral, Julius also integrated a Southern college. There are a lot of stories in the civil rights history about integrating Southern colleges, but this is one you have not heard. Florida Institute of Technology was founded in 1959 as Brevard Engineering College, and its first building was a public junior high school. Because it was a public school, that meant blacks weren't allowed in. When Montgomery signed up to attend classes, the superintendent of schools called the president of the new college and told him that the school would not be allowed to open if Julius Montgomery went to school there. The president of the college begged Julius to drop out and to spare the school. And Julius did. He enrolled a year later. And today, the Florida Institute of Technology offers the Julius Montgomery Pioneer Award annually to an African-American who has made a significant contribution to the community.
We also talk about Dr. George Crothers, who made the most significant scientific contribution to the space program by an African American. The Far Ultraviolet Camera Spectrograph Telescope. It's coated in pure gold and stands on 3 legs, staring out at the void from the Descartes Highlands on the lunar surface, where it was placed by Apollo 16 in April 1972. Carruthers' device allowed scientists to examine UV images of more than 550 stars, nebulae, and galaxies, as well as research the Earth's atmosphere for the first time for concentration of pollutants. The engineering backup for it is on permanent display at the Smithsonian Institution. And Dr. Crothers became fascinated with outer space when he was a child. And here's a brief film about him, narrated by astronaut Mae Jemison, where he talks about his early inspiration.
He loved Buck Rogers comic books.
We headed for the planet Saturn. Yes, sir.
They talk about how they went to Mars and Jupiter. And so when I was in middle school and high school, I found out that in library books that there were books about astronomy.
And here's a video of Dr. Crothers at the Smithsonian talking about how he trained the astronauts to use his telescope on the moon. He's interviewed by Dr. David Dvorkin, the curator of telescopes.
We wanted to observe objects from space and being able to observe stars and the Earth's upper atmosphere from the moon. They came to our laboratory at the Naval Research Laboratory here in Washington, D.C., and we showed them how to operate the instrument and what we wanted to have done in terms of objects that they would observe from the moon.
It must have been a very exciting time for you when the astronauts finally landed on the moon and deployed your telescope out there. Where were you at that time, and what was your job?
Well, I was at the mission control here on the Earth, of course, and we gave information to the astronauts and got information from them so that we could find out if we had to make any changes or find out what kinds of pictures they were getting from their operations on the moon's surface.
Another pioneer we highlight in the book is Clyde Foster. There is no one who did more to promote equal employment at NASA than Clyde Foster. He got more Black workers jobs. He advanced the education of more Black engineering students. The man's accomplishments are amazing. In 1963, when Wernher von Braun was struggling to find more African-American employees, Clyde Foster had an idea. He knew that Alabama A&M, which is the HBCU near NASA, the Black college in Huntsville, he knew that they wanted to bring students into the brand new world of computers.
The Black University wanted to get a computer science program going, and I told this to my center director, and I was able him to place me on loan to the university to establish a BS degree in computer sciences. And I said, maybe this is one way we can get more employees.
By which he means more Black employees, and it worked. There are dozens of African-American NASA employees who started in this computer class. Now, for all of his success, Clyde Foster found that he could never advance. He wanted to be a supervisor, but he kept getting blocked. Marshall Space Flight Center offered advanced training courses, but they only offered them in two places. You could go to the white university to take classes, or you could go to a hotel ballroom, and Blacks weren't allowed in hotel ballrooms.
You weren't allowed in public facilities. And now, in order to advance, you got to satisfy the prerequisites for what the job called for, and they refused to train you.
Clyde Foster worked for years to get NASA to end that injustice too, finally getting them to establish a separate but equal advanced training program for Blacks at Alabama A&M. On top of all this, Clyde became one of the first elected Black mayors in the South. As mayor, he appointed one of the South's first Black police chiefs, and this started a movement all over the South for Black self-government. Clyde credits NASA with making all of this possible.
It had to be, because, man, I hadn't had that experience early in life to cross over into these areas, political, education, business, and all of that was because of the experience I had with NASA.
After the 1963 Birmingham riots, NASA was forced by the government to do more to hire Blacks. And one of the things they did was open their co-op program, their college co-op program, to HBCUs. And the first co-op students from an HBCU came from Southern University in Baton Rouge. When they started at NASA, it caused a sensation in the Black press. The Black press saw these young men going to NASA as an achievement for the nation's African Americans as a whole. The position that the space program held in America at that time was the signal American accomplishment. And these young men going to NASA showed that the Black community, that showed that the Black community was also helping getting the nation to the moon. But it wasn't just the Black press that noticed. This is an article in the New York Times. It called the young men social pioneers. It also said that NASA was having trouble recruiting African Americans to come to the South, where there was still riots and people were still being beat up because they wanted to vote. The co-op students found that to be the case too. The group included Tommy Dubon, Frank Williams, George Borda, and Morgan Watson. For the book, we talked in detail to George Borda and to Morgan Watson. The co-op's experience demonstrated the problems that the New York Times talked about. No one would rent them an apartment when they got to Alabama. They couldn't get a hotel room when they got to Alabama. Morgan Watson told me about a Ray Charles concert that he went to when he was at NASA, where they put a rope down the middle of the auditorium with the Blacks on one side and the whites on the other side so that nobody would dance together. So a recruiter at NASA got them homes in the Black community in Huntsville. Despite NASA's efforts to integrate its workforce, this is the way things were like when the co-ops got there, according to Morgan Watson.
At the time we were there were no black professionals at all. I don't even think there were any clerical workers. I remember some groundskeepers and janitors.
And Morgan said that the young men felt the expectation that the black press and the black community had placed on them.
And we went out of our way to study late, to work hard, and do whatever it took to, well, we felt that the whole image of black people were riding on us as professionals, and we couldn't fail. We had to go forward and do our best.
In an ironic turn, Werner von Braun, a member of the Nazi Party and Hitler's Rocketeer, became NASA's point man on race in Alabama. During a December 1964 speech to the Huntsville Chamber of Commerce, he requested that attendees ask themselves, are you doing everything in your power to strive for fair employment and improvement of racial relations in our city? He acknowledged that we should all admit this fact. Alabama's image is marred by civil rights incidents and statements. And he urged everyone to familiarize themselves with the equal employment opportunity section of the Civil Rights Act of 1964. But by the spring of 1965, Alabama Governor George Wallace's 1963 declaration of segregation forever still echoed in the South. But the end of forever was much, much closer. Lyndon Johnson was elected president with a congressional majority and a mandate to build his great society. The Civil Rights Act of 1964 was in effect, and the Voting Rights Act of 1965 was working its way through Congress. Furthermore, NASA's Huntsville workforce was desegregated, and through agency influence, the city became more so. But Wallace was still the governor of Alabama. State law barred him from re-election in 1966, but his brief presidential campaign in 1964 established him as a national political force and potential presidential candidate in 1968. Against this political backdrop, he scheduled a tour of Marshall for June 8th. His entourage included members of the Alabama legislature, small-town newspaper editors from 16 states, and reporters from major publications like Time and the New York Times. When NASA Administrator James Webb learned Wallace planned to visit Marshall, he decided to come down to Huntsville himself. NASA had to control the tour and contain Wallace. Later, Werner von Braun joked to Webb, he, Wallace, may cancel his trip if he knows that you'll meet him in the schoolhouse door. After the tour, von Braun suggested to his guests that Alabama's hopes for industrial growth were jeopardized by its racial policies. He told the legislators that attracting and keeping the best people would succeed when Alabama offered the same opportunities as other states. Wallace did not come back to Huntsville, at least not for another public event during the remainder of NASA's mission to the moon. Now, tonight, we've only scratched the surface of the topics covered in our book. We also look at how the Black press pushed for NASA to integrate, how George Wallace's stand in the schoolhouse door was supposed to happen in Huntsville as a direct challenge to federal power that NASA represented and an agency employee who wanted to take a math class, and the story of a would-be African-American astronaut, and how one of the first Black U.S. Navy officers became the first African-American to receive a PhD in metallurgical engineering. Now, did any of this matter? Was there any positive impact? Morgan Watson, one of NASA's first Black engineers, certainly thought it did.
The space program certainly helped change the South. Not only NASA, but the whole federal government laid the groundwork from the military on for Blacks to be integrated into the workplace. By showing that there were Black professionals who could do that, you proved the fact that people were available that could do it. It helped to break the walls down. It helped change people's perception of Black people in the South.
President Kennedy said America had to pursue a space program because there were new knowledge to be gained and new rights to be won. and used for the progress of all people. He wasn't talking about American race relations when he said that, but an accident of timing and coincidence ensured that the space program would help win rights and create progress for African American people in ways the president could not have imagined. And in doing so, the space program would help white Americans gain new knowledge about their Black fellow citizens and their abilities. So thank you all for your time. And now Richard and I will take questions.
All right, well, thank you so much for agreeing to give this talk. Really appreciate it. For everyone in the chat, if you do have questions for either Richard or Stephen, please do type them in the chat. We can go ahead and ask them while they're still here. So I guess one question for both of you is, how did you decide to do this? How did you meet each other and decide, all right, let's write this book together. Let's go ahead.
I'll take the first half on that, and Richard can
That's
take
right.
the second half.
That's right.
It began as a lowly graduate student in 1995, where I was told, you've got a semester to find something. This was my chair, to find a topic, or I'll find something for you. And I said, I looked around, science, technology, what about NASA and civil rights? And he said, you have a semester to prove there's something there. Within that semester, a year, I had a grant from the Kennedy Library, a grant from the Johnson Library, and a phone call with the head of the NASA history office saying, nope, nobody's ever done anything like this. It's a great idea. Then I had to prove it was a great idea. So I wrote my my thesis, and it sat on bookshelves like they always do and collect dust while I went off to pay off my loans. And then Richard comes in.
Then 20 years later, I was at a conference, a NASA conference on the human impacts of spaceflight, by which they meant the impact of the space program on journalism, on religion, on things external to science. And somebody got up and gave a talk about how we need to look in different parts of history when we look at the history of science. And he mentioned, what did he say? What was the adjective? This amazing or outstanding or something thesis that I read by someone named Stephen Moss about civil rights and NASA. Now, I'm a documentary producer, and I was looking for a topic, and I thought, civil rights and NASA, wow, yeah, the space program, sick 1960s. Civil rights, 1960s. How come nobody's ever put these together before? And so I went to the friend who had invited me, who was had been the head of the NASA history office and was now at the Smithsonian. And I said, you got to find me this paper by this guy, Stephen Moss. And I read Stephen's paper and I said, this is amazing. And I made Stephen the principal voice in my documentary, and it aired on public radio stations all over the country. And then Stephen got in touch with me and he said, would you give me all your information because I want to write a book? And I said, no, I won't do that. But if you'd like to write a book.
Is that both of us through the years were told by our various friends, you need to write a book before somebody else does. I was never going to write a book the way I wanted it to be without a whole lot more money and information. Richard certainly wasn't going to, which meant we had to team up.
That's right.
Because we didn't want anybody else to write this book. This was ours. And I think what's important is that Richard and I only did the entire book through email and sometimes stressful phone calls. We were never in the same state until the book was actually written.
So the first time we met, I think, in person was the day that we were giving a talk at NASA headquarters.
Oh, it was the day before. It was
That's
at,
right. We were giving a talk at the Smithsonian.
Yeah, we met at the airport. We'd never even seen each other.
That's right.
And so we had three rules.
What'd you say, Michael?
Oh, go ahead.
No, okay.
No, we had three rules that our publisher was amazed that two people who'd never met could agree to. One is we keep our egos in check our egos at the door, which was harder than you think. The stories come first. We have to get the stories right for these guys. And because we're the first book like this, or we were hoping to be the first book, we had to get the history right. Because if we didn't, all the serious history people wouldn't take our book or these stories seriously.
That's right.
And I think we hit all three.
So that's that story.
Very cool.
Yeah.
I was gonna say, I think that's like every
Pretty much.
grad student's dream, that someone finds their thesis somewhere. It's like, oh, this is
Mhm.
amazing. Not only that just somebody reads the thesis, but they actually like the thesis.
Yeah.
So going through, I guess, some stuff that you hadn't touched in the talk when I read the book, there was a really fascinating part about a study that was funded by NASA to look at the actual effects of NASA and its effect on society, written by, I believe, it was Peter Dodd. And
Right.
so I'm wondering if you could say a few words about what it found and if NASA took any action based on that study.
There was this idea that was sort of prevalent in the 1960s that science was either above society or science was separate from society, and that scientists were separate from society, and that they were separated from societal ills. And there was a study that was funded to send a sociologist to the space communities in Florida, Alabama, Texas, Louisiana, and Mississippi to talk to space scientists, to talk with the engineers, to talk with the people who were designing the rockets, and see what their attitudes were towards God, towards race, towards politics. And they found, well, go ahead, Steve. They found, I'm a Northerner, so you're a Southerner.
What they found is there was a presupposed thought that the technicians, especially technicians coming in from northern, less segregated states, that they would be more socially conscious and liberal, which was not the case at all. For most of them, if they were technicians or working for one of the contractors, they were there for a few years and then they'd move on to another aspect, another phase but basically it just proved that they supported better roads and sewers in their communities because it meant a better life for them, not because it was just the right thing to do. They didn't necessarily improve the education system. They did bring in a whole lot of tax dollars to fund schools, which weren't necessarily desegregated.
That's right.
There wasn't a lot of change. There was the myth that these legions of white technocrats coming in from the north would change Southern's life. Didn't happen.
And something else that
most of the employees were from the South anyway.
That's right. That's right.
Yeah.
That's right. Yeah. And NASA in the South hired from the South. And there's really no reason to imagine or think, as Julius Montgomery's experience showed, that people who live in a society are going to have opinions that diverge particularly greatly from the people who live around them just because they work in a scientific or an engineering community. That people are people, and that people's attitudes are often exactly the same as their neighbors' attitudes. It doesn't matter what kind of job they have.
Yeah, it's something that I admit even I kind of thought about going into academia is you have this image of everyone's educated and enlightened, but a lot of some of the systematic racism can still persevere even through academia. So I guess kind of following up on that, then how do you see NASA today? How has it learned from the 60s? Has it successfully implemented, equal like diversity hiring requirements? How does NASA stand today compared to the 60s?
Well, obviously it's improved from where it was 50 years ago.
Yeah.
But NASA, and I will pick on NASA because they're the topic of our conversation, but I don't think they did a lot of things differently than other federal agencies. when they needed to hire a more diverse workforce as far as gender, they didn't hire necessarily women of color. They would hire white women. And so women of color were excluded, but NASA was showing that it was hiring women, and that helped with that demographic. One thing, without
Before
getting
you move on from that, Stephen,
I think I may have just lost audio.
Pardon? Oh,
checking on it.
Can you hear me?
Weird.
Yeah.
Can you hear me, Michael?
Well, I think it's showing up in the
Okay.
YouTube stream, so I think you're okay. I think it's just on my
Okay, well that's fine. So another thing, I'm doing research right now for a Smithsonian exhibit on women in the space program, and I interviewed somebody who was the first African American woman to run a science or engineering.
There we go. All right, hold on 1 second. I'm sorry, my audio has just like completely reset itself, and now I have to set up so that the audience can hear you because apparently the audience cannot hear you right now. We were doing so good. We were doing so good with everything working out, and then okay, can you say something now?
Can you hear me? Can you hear me now?
All right, I think we're good.
Okay, great.
Sorry.
the last thing that I said, if nobody heard it, I just finished a project for the Smithsonian on women in the space program, and I interviewed the first African American woman to be hired to run a science or engineering division at NASA in Alabama. And she had worked there for years, and despite having an Ivy League graduate degree, she could not get a promotion. And she did not get a promotion until she sued for sex discrimination and race discrimination and won. And then she got a promotion at NASA.
There's something else observational. When we were giving talks at NASA facilities and the issue would come up, that type of question, if you watch the audience, people of color and women would nod their heads or shake their heads about problems still existing. They wouldn't say anything out loud, but you could see their expression and we could see the heads moving. It's like, maybe we wrote current events instead of history here. But we want to say NASA did the right thing. And it did to a degree. Was it perfect? Is it perfect? Not hardly.
Okay. And then just another question that I've had reading the book, again, not necessarily in the talk, but the origin of Cape Canaveral, of this building where they assembled all these rockets, where it was founded in, I believe it's Brevard County, Allentown?
Brevard County.
Brevard, yeah. Yes.
Right. So Cape Canaveral was an Air Force base. It was a small plot of land. I don't know whether any of you have ever been to Cape Canaveral. Steve and I got to go down there and give a talk. It is massive. And in 1964, NASA bought all of the land around the Cape Canaveral Air Force Base to build what's now the Kennedy Space Center. And most of the land that they took had been a town called Allenhurst that had been founded by free Blacks who had served in the Union Army. They were Black soldiers from North Carolina. And, as their 40 acres and a mule that they got from the government after the Civil War, they were given this town. It was some of the worst land in Florida. It was on a river that at the time was called the Mosquito River. So it was just bug infested and mangrove swamps and so forth. But these people were able to establish a community. They built schools, they built businesses, they employed each other, they educated each other. And it was this wonderful little town called Allenhurst. And then NASA came in to build the Kennedy Space Center. And the way that they did that was to completely wipe out the town of Allenhurst. And one of the people we talked to in the book, Theodis Ray, was born there, grew up there, got a job at NASA as a janitor, said, the hell with this, joined the Marines, went to Vietnam, came back from Vietnam, went back to NASA. They said, well, you can be a janitor. And he said no. And he went to one of the contractors and got a job running this enormous warehouse facility on the base. And he still gives talks to people about the history of Allenhurst. So when we gave the talk down at Cape Canaveral, a bunch of African-American NASA employees came up to us afterwards and said, where's this Allenhurst? We want to go find it. And I said, Mr. Ray is standing right over there. Go ask him. He'll take you there.
Very cool. So, all right, one last question then, I guess, one for each of you. What was, I guess, one thing that really stood out from you from this project that I'm gonna put you on the spot here, I guess, what was like something that really stood out for you, something that you learned that you never would have suspected from this research, or something that just really stood out for you?
Go ahead, Richard.
Oh, great.
It's an easy question. I mean, come on, you get this all the time, right?
I don't know how many of the people in the audience are old enough to remember the stand in the schoolhouse door. So this is when the governor of Alabama was told by the federal government that he had to integrate the University of Alabama. And he said, hell no. He had given a speech at his swearing in where he said segregation now, segregation tomorrow, and segregation forever. And he decided that he was going to stand up to the Kennedy administration and tell those liberals from Washington that Alabama wasn't going to integrate its state university. And the thing that I did not know and was astounded to find out, the stand in the schoolhouse door was in Tuscaloosa at the main campus. Until the day before, it was not going to be in Tuscaloosa. It was going to be at the new branch of the University of Alabama in Huntsville. And the reason why is because NASA was in Huntsville. And he felt, if I really want to stand up to Kennedy, I'm going to do it in NASA, in Huntsville, at the university next to NASA, to really stick my thumb in those Yankees' eyes and say, no, we're not going to integrate. And at the very last minute, he decided to do it in Tuscaloosa. And the reason that he wanted to do this in Huntsville was because two guys wanted to take a math class. So I said the pettiness is the thing that sort of shocks me. When you think of segregation on a grand scale and you think of white supremacy on a grand scale, you think about it in grand terms. And the thing about talking to these individuals is to learn about the tiny little, just aggravating, miserable, horrible things that it does to individual people on an individual level. So I think those two things are the things that were the most eye-opening for me.
So for me, it was having enough to actually graduate with my degree. That I proved my well-meaning professors wrong, and there was material there. It was a story nobody had thought important enough to tell. And I got to be in on the floor. And the other is less any of the stories, although some of them were very surprising and obviously things none of us knew until the book. But it's the response to the book. It's that we got this story out while so many of these pioneers were alive to see the book. Their children and their grandchildren didn't know these stories. We not only got it right, we did something right with this. And this is The book came out in 2015. And so we're 6 years after the book comes out, and we get to talk to Astronomy on Tap at Penn State.
It's the highest honor you've ever received, man.
We've waited all these years for you to call, and now you have. So this is it. We're still getting to share these stories, and people are still learning and being amazed by the individual acts of courage, and in the case of Julius Montgomery, insane acts of courage. And that, through the years, has what stayed with me the most. The families get to hear the stories and get to have a permanent piece of their father and grandfather and great-grandfather's history on the shelf that otherwise would have died with it.
Very cool. Thank you so much for coming out to give this talk. We could not fail. Go check it out. If you haven't, really love the book. Thank you again.
Thank you, Michael. Thanks so much.
All right. We are going to get our trivia answers with Arvin, figure out who won trivia. So go ahead, Arvin.
Yeah, again, thank you, Richard and Stephen, for that great talk. I haven't read the book yet, but it's now near the top of my list. That was really nice. Okay, so the answers for tonight. Thanks everybody that submitted something. I'll just go through these now. So number one, what is the current phase of the moon? The correct answer for tonight is that it is a waxing gibbous. The moon fills up kind of in a non-intuitive way, I guess. It fills up from right to left. So you'll start to see a crescent on the right, and then it'll get to the first quarter, and then gibbous, and then full moon, and then it will empty out again, going the other way. So this is a waxing gibbous, not a waning gibbous. Number two, which of the lunar maria has the greatest diameter? The correct answer is Oceanus Procellarum. This is the only one that has the name ocean in it. All the others are just mare because they're smaller. This is also the Sea of Storms, as somebody in the answers pointed out. Number three, which Apollo 8 astronaut took the famous photograph Earthrise? Correct answer is Bill Anders. Although two of the answers I really appreciated were Grucke and Tony Hawk. So here's Grucke being Tony Hawk for you all. Number four, how many times weaker is the gravitational acceleration on the surface of the moon relative to the Earth? It's 6 times weaker. You'd weigh 6 times less. Number five, which is larger, the moon or Pluto? I think most people got this one correct. The moon is actually slightly larger than Pluto. Number six, which of these landing sites was the location of the first lunar landing of Apollo 11? That was C. It was right here. Number seven, how long does it take light to travel from the moon to the Earth? It's about 1.3 seconds. I accepted anything from 1 to 2 seconds just because I wouldn't expect anybody to know this exact number. I certainly didn't know that number. Number eight, roughly how many days does it take the moon to orbit the Earth? The sidereal orbital period of the moon is 27.3 days, so 27 would be the correct answer here. I think the synodic period is a little over 28 days, but that's not what I was asking for here. Number nine, how much fainter than the sun is the moon? The full moon is 400,000 times fainter than the sun. 10, what fraction of the lunar surface can be seen from the Earth? It's about 60%, so I accepted anything from 55 to 65. And as Jacob pointed out, actually, this would give away the answer to number one, where you can see the moon filling up from right to left and then emptying out. Number 11, how many people have walked on the surface of the moon? The correct answer is 12, but maybe I should have specified humans and not people, because maybe some alien people have, and that would put the number higher. Or again, maybe the government knows more than they're telling us. Another fun fact, though, is that all 12 of those have been Americans. They've all been American astronauts. Nobody else has yet sent somebody to walk on the moon. Number 12, how many degrees is the moon's orbit inclined? The correct answer is 5 degrees. I accepted anything from 3 to 8. Number 13, how did the lunar maria form? The most likely explanation for this was volcanism on the moon, obviously without the trees and the water, but volcanism and lava flows are what carved out these maria. Number 14, which Apollo 11 astronaut piloted the command module while his crewmates landed on the moon? Michael Collins. He famously was on that crew with Buzz Aldrin and Neil Armstrong, but he got to stay behind while they got to make history. And number 15, was the Apollo 11 moon landing a hoax? The correct answer, as Luke tells us, is no, but some other answers that people posted in the sheet were the moon's fake. It's a cheese wheel in a studio in Hollywood. I guess that would make it a hoax for certain then. No way, Jose. Jury's still out. And my favorite was yes. Whoever you are, you automatically lost this round of trivia. Tonight's winner. They were incredibly creative with their team name, actually. This is the full team name here. There was a tie. 2 teams had 11 points, but I couldn't pick anything over this one, of course. Their team name was the team that likes the hypothesis the Seven Sisters are so named in many disparate cultures because 100,000 years ago, the naked eye could discern Atlas from Pleione, giving 7 visible stars. So currently, in normal, very clear conditions, the naked eye can distinguish Atlas, Alcyone, and these 4 other bright stars, which is only 6. And it's actually really difficult to distinguish more than that, except for very, very, very clear high altitude sites. But I guess the theory that this team has is that Pleione and Atlas actually moved over the past 100,000 years. So Pleione would have been further away and easy to distinguish. So some fun astronomy facts from our winner's team name. We will contact you after this or actually, I forgot to put a box in the answer sheet for your email. So if this was you, if you were this team, please email us at astroontapsc@gmail.com. And we'll get back to you with details about getting you your prize. So I apologize for not putting the email in the form there, but we will make sure you get that. Thanks.
All right, thank you, Arvin, for that. Thank you again to all of our speakers. Thank you to Brianna and Jacob, who are still hidden. There's one of them. There's the other. All right, so thank you so much for coming out to another fantastic Astronomy on Tap. We will, of course, be back in February, so please stay tuned to our Facebook page, our Twitter, our YouTube, all of those things. Like and subscribe. You know what to do. You know how YouTube works. So stick around for another month. We'll see you back in February. Thank you.